Hello, hello. Are we live? Cool. Welcome back to Advent of Syntran 2024. This is day 20. All right. I was actually thinking about doing this one at midnight, but after streaming for 3 hours yesterday, I was not up for it. If we get an easy one, maybe I'll do that tonight. I don't like my chances, though. We're on day 20. It's probably going to be hard. Oh, my Twitch bot is not running. Okay, that should be up momentarily. All right, let's download the input. 20, we're getting there. Another grid. We have an S. Do we have an E? We have dots, hashes. E is in line 120 out of 140. S is at 140. This looks like a maze. It looks a lot like day 16. So what do we have? Racetrack. Doesn't look like a racetrack. There's no loop. Racetracks are supposed to have loops. I mean, you can have a sprint, but if it's a racetrack, it should be a circuit, shouldn't it? Oh, race condition. All right. Nanoseconds a few days ago. Now we've got picoseconds and mutices or mutexes. There are no forks. I mean, there are twists, but there's only one path. Can you go through the walls or something? Okay. There are no forks here. What? Yeah. Okay. Oh, God. Do they have to be 2 consecutive picoseconds? Hey, Vision for All. How are you doing with Advent of Code? All right, where do we cut through right there? Yeah, part 1. I just started, so like I'm not even done reading the puzzle, but this sounds difficult. Okay, so this was a wall, and then we passed through it right there. Why? So you could pass through a thicker wall, right? Okay, so where's this? Well, I can look right. Okay, again, you don't really need the second picosecond. I don't really get the rules. Like if you can if you can cheat for 2 picoseconds, could you pass through a wall of thickness 2? Like they don't show that in any of the examples. But it's kind of a bad example. There aren't, like, why would you pass through the wall in this direction? Because then there's a third spot there. Let me look at my input and zoom out. That's... I don't think you can do it. I don't think you can go through a wall of thickness 2, because like it doesn't really appear anywhere. We get walls of thickness 3 down here, but I don't really see any walls of thickness 2 that you could pass through. I'm kind of tired of searching. We've done this so many times this year. Okay, at least I don't have to do the junction optimization. Did I have to do that? Yeah, I can't remember how much of day 16 I got on stream. I think I only got part 1 on stream. Okay, let me get the test input. This is 15 by 15. That's not really the test input, because it has a cut through the wall. That's the map. Okay. Syntran, not syntarn. All right, so that's the input echoed. So first I have to find the start position, I have to find the end position, and then I have to find the usual path. Do I have to find it? And then how am I going to do part 1? I think I might just brute force part 1 by removing every wall. Okay, yes. So you do have to find the usual path, because you have to know how long that is. And then you need to know how much the shortcuts save you compared to the usual path. So I have to find that first. And then, yeah. Except, I guess you don't really need to try removing the edges, because that's obviously not going to be a shortcut. The top or the bottom or the left side or the right side. And then the brute force approach would be try removing one hash and then see if you can find a shorter path. Is there any way you can optimize that by like making the graph for the usual path and then just like making an edit to the graph instead of building a whole new graph from scratch? Except for that one point, there's going to be like one more node and 2 extra edges potentially. Like if you iterate brute force and you try removing these, you might find that it will add a node, but it won't add any edges to your graph if you remove one of these. So I think you could do that. But do I actually explicitly build the graph? I don't know. Yeah, there's probably some graph algorithm where you can take a graph and then make an edit to it and then find a new shortest path without like starting from scratch. But I don't know enough about graph theory to have any idea what that algorithm would be named or how to find it. Okay. Yeah, day 20. This is my template, and I can use one of my fancy helper functions. I can say let chars equals read char mat file name, and then print char mat chars. So instead of printing strings line by line, this should print this just as characters without any prefix. There we go. And this is actually in a matrix in memory. It's hard to tell what type this is because I just have type inference, but this is a rank 2 array of characters. You did a simple thing for every position in a track. If in a direction there is a wall and then a position on a track, it's a shortcut. Yeah. So like here, if I remove one of these, you can see that it has no neighbors that are open. So that's not going to be a shortcut. But yeah, if it's yeah, if it has opposite directions that are open, then that's a shortcut. Yeah. So I think I see how to find which things are shortcuts, but I don't know how to like do the graph search again. I guess. Yeah, I guess you could find the regular path and then see like from here to here, that's a certain distance. Like it's a distance 1, 2, 3, 4, 5, 6. It's a distance of 6. And then if we remove this, it's a distance of 2. So we went from a distance of 6 to 2, we saved 4. Okay, yeah, I think I get that. So I don't really need to search the whole graph from scratch. All right. Okay, when did I do this? What was day 18? What did I use BFS for here? Okay, this was a grid. Oh, this was the falling bytes. Okay, yeah, so I think I'm going to copy this because breadth first search will find the shortest path. And then I also want a dist matrix. So this has some scalars named dist, and it has the distance from the end, but it does not have the distance of each point. So I think if I save that, then that's not what I want to look at. I can say this point has a distance of 1, 2, 3, 4 from the start. And then this point has a distance of 10 from the start. I remember it was 6 away from this point. So that would be 10 from the start if this is 4 from the start. And then you can figure out how much time each shortcut, or how much distance each shortcut saves you by seeing which points you can cut between. So in addition to a visited array, we're going to have a grid of distances. That's the same size as the grid. I need to get this. And I also need to find my start and end locations. Okay, yep. Part 1 doesn't seem so bad. I think I'll be able to do this. All right, now we need to find those. I need to get the size of the grid. Let me turn down the volume on my other computer. Actually, I don't know if it's this one that's making the USB noise or if it's my work computer. All right. If it's if it's my personal desktop, that should be quieter now. All right, so we're gonna find the start and the end. Is it uppercase? Yeah, it's uppercase S and E. Start and end. This probably won't compile. Do I need a queue? Yeah, I think I need exactly this queue. Okay, yesterday, I think I edited. But part 1, did I use a queue in part 1 yesterday? I don't know, I'll just write it from scratch. I don't think I need this, but I want to see if I get the right answer at least. But this is not the end position. Okay, what am I pushing? That's the wrong thing to push. Let's It's going to be the start location and a distance of 0. So the queue has X and Y in distance. So the initial distance is 0, and then the start is the start location. I think all of this should be okay. This condition is wrong. I don't think I really need this entire conditional block anyway, but X end, Y end, DIRs, I think I need directions. I don't think I need the west, east, north, south part, but I'll copy that just in case I need them later. You never know what's going to be in part 2, so it doesn't hurt to have that. Bounds checking. Okay, now grid does not exist here. We have a character grid, not booleans. So if chars is a wall, we continue. Pushing should be okay. And then, yeah, that should find the usual path without trying to do any shortcuts if it runs. NX. I think I just want to cast those down to I-32. Our problem is like 150 or 140 by 140, I think. Okay, 84. That sounds about right. Yep, 84. Picoseconds. If you want to think about it as units of time, I would prefer to think about this as units of distance. But if you're moving at a constant speed, then distance and time have a 1-to-1 relation. So whichever way. Advent code is funny sometimes. I think they're like, well, we already did like 5 distance problems this year, so let's pretend this is a time problem, but basically has nothing to do with time, in my opinion. I shouldn't be so critical of Advent of code. It's really fun to participate in. I really enjoy it, and it's a lot of work. Like, imagine not even just coming up with the puzzles, but then like making inputs that are unique to each user, that are solvable and have a well-defined answer. Like, that's a lot of work beyond just like coming up with a puzzle in the first place. Like, I have to write the code to solve this problem, but Eric, and I don't know if it's just Eric or if he has a team of people or what, but they have to come up with code that generates unique puzzles. So that's like an inverse problem, which might be, it's definitely more difficult than solving a problem. You have to generate every possible input for the problem. I mean, not every possible input. I don't actually know how many inputs there are. Are they really unique for every user, or is there like 100 of them? And, you know, every user has a 1% chance of getting a certain input. All right, so we have the usual path. Now we have to find the shortcuts. So, so we found those locations, and then so that's without shortcuts. And then we're going to start looking for shortcuts. This is not really the answer. But it is useful to know. And then do it. I don't think I actually need to know that. You want to know how much time you save relative to the usual path. So you don't really need to know how long it takes you to get to the end. Unless, of course, you have a shortcut that takes you directly to the end, and then essentially you have to know it. What I do care about is this array that I forgot to set to anything, which is dists. So I mean, we have this visited condition, and it's a breadth first search. So on a non-weighted graph, which is what this is, breadth first search will only find the shortest paths. So as soon as it's visited, we're never going to see it again, and you don't actually have to take the min like this. Yeah, you know what? This is definitely not required. So this entire branch is not needed. And then I don't want to print that. But I will want to print dists xend, yend, and that should be the same thing once I get this set. Ye, and then I can set it right here before I continue. No, you want to do it after. Yeah, that's the difference. If you do it before, you have to take them in, but if you do it after this visited check, then you'll definitely get them in. So dists x naught y naught equals dist naught. And then I want to print, well, let's see if I get the final one correct first. It should be 84, like we already got. Yep. So that's the same number, but now this is an entry in an array. It's not just the distance of the end. I now have the I should have the distance of every point that's not a wall. All of the walls will be initialized to -1. So I should be able to look at all of these. And it should be like 0 for the start, 1 here, 2, 3, 4, 5, 6, 7, and -1 everywhere that's a wall. 0, 1, 2, 3. That looks pretty much like what I expected. And then if you go from the end, it counts down 84, 83, 82, 81. That looks like it makes sense. And then it's -1 everywhere that there's a wall. Okay. Don't think I need to see all of that. And then now I have to look for shortcuts. So a shortcut is if the east edge and the west edge are open, or the north edge and the south edge are open. And then you have to take the difference in the distances between those 2 points. So we're going to scan the entire grid again, just like we did to find the start and end locations. And then what do we do? So I guess it was useful that I saved these, because now I can have things that are readable. Except I don't want to loop like that. I know the top edge and the bottom edge and the side edges, those can't be shortcuts because you're not going to like jump out of bounds. So I can actually start the loop at 1 and end the loop at the upper bound -1. And then this also helps us because then we don't have to do any bounds checking inside this loop. So that's a win-win. Okay, now if west and east are open, or if north and south are open, Do I want to have two cases that are copied pasted? No, I can save variables. Okay, so we're going to have the east position, which is x, y, plus dirs east. I know I'm going to want a space right there for vertical alignment. East, west, north, and south. East, west, north, and south. West, north, south. Okay. Then I think I know what's coming in part 2. You can take a shortcut for more than 2 picoseconds. Yeah, that's going to be wild. I don't want to think about it. That might not even be right, so there's no point to worrying about it yet. Okay, now let's get the characters at those positions. Yeah, probably could have done this with like an array of rank 4. East, west, north, south. East, west, north, south. East, west, north, south. Okay. No, I'm not going to use a boolean. I think I'm just going to copy and paste everything. I probably should have done this a different way, but now if that's a dot, actually, I want to have an earlier continue. So we only want to check walls. Like obviously you're not going to have a shortcut through something that's not even a wall to begin with. So if chars xy is not a wall, continue. Do I check for literal dots anywhere? Yeah, so I shouldn't be checking if it's equal to a dot. I should be checking if it's not equal to a wall, because we also have the start and end locations. Yeah, I could just fill those in with a dot so that I don't have to worry about the difference, but for now, the way I've done it, I want to see if it's not a wall. So, and west, not wall. Then we have a shortcut. Oh. Okay. So you want to make sure you only count each shortcut once. And they say uniquely identified by their start and end position. So if you're going from here to here, that's going to save you distance. But if you go from here to here, that's going to increase your distance, actually. So we could just look at the sign of this number here to see if it's half of the shortcuts that we should count. I'm actually going to get both of them. No, because I'm iterating on the walls. Yeah, so I just want to take the absolute value. So I'm not going to have any problem with doubling. but I do need to take the absolute value here. It's dists p, it's going to be the absolute value. 0, 1 minus dists p west 0 and p west 1. And that's how much time you save. It's a difference between two distances, so it's already relative compared to the usual path. So this is essentially the list of numbers that I'm looking for. It's not the final answer, because we get a list of numbers, which is like 2, 4, 6, 8. And then we want to count how many of those are greater than or equal to 100. And that's going to be the final answer. But this should print the list of all of these things. Well, this is going to be half of them. This is only the east-west shortcuts. I'm also going to have to do the north-south shortcuts. And I have like a bunch of duplicates. Yeah, so there are actually 14 that save 2 seconds or 2 picoseconds. I think I'm not going to count all of those. Part 1 is, yeah, I was intimidated at first, but at this point I feel like it's not that bad. Unless my code runs for like an hour on the real input and there's like something that I have to optimize. Yeah, so I think I'm not going to check the counts of how many of each of these there are. I'll just see, like, did I get a 64? I think I got a 66. So that doesn't seem right. Oh, yeah, some of these are... No. I'm only checking wall to wall. So how did I get a 66? What's up with that? Oh, I'm off by 2 because my shortcut is actually a distance of 2. So this is actually abs minus 2. And then I'm off by 2 for all of them. Okay, so now I have a 64 and a 20 and a 10, a couple 10s and a 12, 20, a couple 10s, a 12. Is there a 40 and a 40 and a 38? Those might be north-south shortcuts, so I have to find those. Subtract that. Okay, so those are east-west, and then I want a north-south, east-west. Let me find all the E's. It's going to be north. And then find all the W's. That's going to be south. Okay. So now we have a 40 and a 38 and a 36. Okay, there is a 36 there. Yeah, I'm confident that this is right. Yeah, let me actually initialize diff. And then I at least don't need to have this part inside the condition. Don't even need brackets there. Okay. Now, Probably don't even want to print all of them. So if diff is greater than or equal to 100, then add 1 to the answer. And it's going to be 0 for the test input because the best shortcut is 64, and that's not greater than 100. Yep, so that's 0, and then let's try the real input. I've got a good feeling about this. I just hope I'm interpreting greater than or equal. So if you save 100 picoseconds, 100 is at least 100. So I think that should count, so it should be greater than or equal. Okay, that's part 1. Part 2, I think we're going to be taking shortcuts for longer than 2 picoseconds. Yep, 20 picoseconds. Oh. So this is actually the taxi cab norm, or the Manhattan norm. So it's just the y difference plus the x difference, absolute value. So I think what we could do is we can iterate through pairs of points on the path. So like, I'm going to iterate through every pair, but you could pick 2 points and then get its taxi cab norm of the difference between those positions of those points. You don't have to do any searching. You just have to get the absolute value of the difference of the x and y positions and add those up. That's the taxi cab norm, or the Manhattan norm, or the 1 norm, or is it the infinity norm? I think it's the 1 norm, if you want to be mathematical. And then see if that's less than or equal to 20, and then that's a valid shortcut. You don't even have to know which walls you go through. You just have to know that there could be a way for you to get a shortcut there. Yeah, and you don't need to use all 20 picoseconds, so it can be less than or equal to that. I think I can do this. Like I have a strategy in my head. How many points are on this path? It's not that many to just iterate through every pair. I think I got this. All right. Thanks to Vision for All for the tip in part 1 though, because I'm not sure if I would have thought about it that way. I think I got through part 1 quickly enough. All right. I don't think I'm logging too much. I'm logging the characters, but I'm not like logging anything while I iterate. Okay, let me take part 1 and not even bother cleaning it up, and then copy that to part 2, rename that, print something else at the end, and then call it. Call part 2. So this should just run part 1 twice. I want to go back to the test input. Okay, that's running twice, and then 1521. Pretty sure that's what I submitted. Okay. Yeah, so the key thing here is that you don't have to do any searching. Like you don't have to do any breadth first or depth first or any Dijkstra or anything fancy. Just iterate through pairs of points that are on the path. I'm actually going to do a little bit more than that. I'm going to iterate through every pair of points in the grid and then check if they're not walls. That's just slightly easier. And then I know the distances. So The only key thing is that you have to take the taxi cab norm, because like you're gonna zigzag somehow, and no matter how you zigzag, the shortest path between S and 6, it's gonna be a distance of 6. No matter which way you drive through the streets of Manhattan, it's the same Manhattan norm. Yeah, that's why they call it the Manhattan norm, I guess. Okay, so part 2. We're still going to have to do all that stuff. We're still going to have to do the initial BFS. So I kind of lied when I said you don't have to do BFS. You do have to do one BFS unless you like have a hard-coded assumption that there are no forks. I feel like you're still kind of doing BFS anyway, no matter how you implement that. Okay, there's a little dead code here. I'll clean that up from part 1 as well. Okay. All right. So instead of doing it this way, I'm going to have a double spatial loop. I'm actually going to have a quadruple loop. Yeah. X1. What's the deal with my edges? Do I ever have a path on the edge? What's going on here? Okay, those are all the hashes. Can't really see the top right corner. Okay. So it looks like we have hashes all along every edge. So I can still skip the outer bounds. I can start looping from 1 and only go up to ny minus 1. That should be a colon. Oh boy. If you do a typo like this in syntran, that's going to fuck you up because this is still a valid array. So you're going to get a loop that goes through 2 iterations. It's going to do 1, and it's going to do ny minus 1, and nothing in between. So I don't know. Should I guard against that? That's kind of just like built in as a feature in my language. Like the feature of syntran is that there are lots of compact array expressions. So this is a range of values, and then this is a comma separated list of 2 values. And you can loop through either of them. Yeah, so we're going to have x1 and y1. Whoa, that's x. That's y, actually. And then we have x. And then we're going to have y2 and x2. Iterate through pairs of points. And then we only want pairs that are both in the path. So I could actually put a continue here. You can optimize a little bit. So it's like the opposite continue as this. So in part 1, I was cutting out walls. Now I'm actually starting with dots or S and E. S and E are also valid points that are on a path. And then instead of cutting out walls, I'm finding a shortcut between 2 points that are already on the path. So it's kind of like an inverse of part 1. So if it's, I want these to be dots. And then if it's a wall, I'm going to continue. X1, Y1. If it is a wall, I will continue. Does that work? And then the same thing for X2, Y2. Sorry about the indentation. This is kind of a crazy way to write things, but I don't want this to be like indented by 4 levels because it's inside 4 for loops. Conceptually, it's like one iterator. Continue. Okay. Does that parse at least? Okay, that is valid syntran code. Let me go back to the test input. It takes a second. I think it's not going to take that long. After you do the initial breadth first search, I guess you could also build up a list of points that are on the path and then save some work in this big ass loop. Actually, let me see how long the empty loop takes. Hopefully it's not like more than a minute. By the way, there is clearly no optimization in syntran. If you have loops that don't do anything inside the loop, it still evaluates them. So that's why this is taking a second. Okay, 35 seconds. I'll live with it. Later, I might, you make a single pass. You have one of these double nested loops, and then you build up a list of points that are valid. And then you don't have to nest this one. You'll have to do 2 passes though. So instead of 4 loops in parallel, 4 nested loops, you're going to have 2 nested loops and then another 1 nested loop, I guess. Actually 2 nested loops, but it's going to be pairs of points, not quadruplets of coordinates. It's not difficult, but if it only takes 30 seconds and it's much faster for the test input, I'm not going to bother with that right now. I might stay up till midnight and try day 21 here in a few hours, so I kind of want to save myself for that. Okay, so we know they're not walls, and now we want to check the Manhattan norm, or the 1 norm. So that's going to be abs x2 minus x1 plus abs y2 minus y1. And we're allowed to do a shortcut of less than or equal to 20. Is that the rule? I think they said at most 20 is allowed. At most 20 is allowed. Okay, so I was confused in part 1 as to why this counts as a 2 picosecond shortcut as opposed to like 1, because you're only cutting through 1 wall. Now I get it. It's like the difference between the start and end points that aren't a wall. That makes a little bit more sense now, because then that easily extends to part 2. Don't need to use all. Up to and including 20. Okay, so if it's greater than 20, I'm going to continue. And that's, I think that's it. So if norm 1 greater than 20, continue. And then, yeah, just like we got this diff, it's going to be the absolute value of the difference of the distances from the dists grid, and then subtract norm 1, because that's the distance that the shortcut takes. And then that whole expression is going to be the amount of time that you save. Okay, but it's not PE. It's going to be X2, Y2. And then X1, Y1. And then in part 1, we only had shortcuts of length 2. Now we have a shortcut of somewhere less than or equal to 20. So instead of subtracting 2, we're going to subtract norm 1. And then let's... I think I'm just going to get this. I don't... 3 cheats that save 76. So maybe I can hard code 76 and see that I get 3. Okay, what did I just do? I thought I yanked that line. So that's what I really want to do. But let's make this 76 just as a test. And I should get 3 with the test input. Let. Right, because yeah, now I don't want to do the absolute difference because I'm not doing unique pairs of points. I'm doing every combination of 2 points, permutation of 2 points. I'm doing each pair twice because of the way that I have these loops. So I don't want to take the absolute difference. I'm just going to refactor this a little bit. So we're not going to subtract the norm yet. And then if diff less than 0, continue. And then diff minus equals norm 1. That should get me just unique pairs of points because I'm now checking uniqueness by the sign of this difference, not the difference including this, just this difference. So it should be 3. Why did that not change? Oh, yeah, because I'm still taking the absolute value. That completely defeats the purpose of what I just said. There we go. That's 3. I'm glad I did the test because I would have missed that. I was ready to just jump to the right answer. So I think that should do it. I have to actually switch to the real input. Let me get rid of this dead code. This is actually shorter. Is that? This is shorter than part 1. Because part 1 we had all of these east-west cases. So part 2, if this is correct, that's not a given yet. If this is correct, part 2 is less code than part 1. Yeah, I still have to run the real input. It's going to take like 30 seconds at least. Probably more like 40 seconds because now I'm actually doing math inside the loop. I don't just have 4 nested empty loops that are otherwise empty besides the other loops that are nested in them. I've got a good feeling about this. Give it a minute. Should be less than a minute. My bet is 40 seconds. Under 41 seconds. I feel like it's been longer than that. It was like 35 seconds and change. I might not be able to scroll up far enough, because I ran the test input a bunch of times. Yeah, 35.8. Are we done yet? Okay, over a minute. Not great. I can't optimize it, like I said. You can iterate through it once and build up a list of points that are in the path, and then only the later iteration, only iterate through pairs of those points instead of doing a quadruple loop over the whole grid, including walls. Okay, so that's what I want to copy. A little over 1 million. There we go. Not bad for day 20. I've got a perfect record so far. Haven't missed anything yet. I did have to cheat on at least 2 days, maybe 2 or 3 days. Like I had to look at other people's Python code to get part 2. That's what I did yesterday. I did look at somebody else's Python code, but it was recursive. And then like I had to do something totally different because I don't have recursion in syntran. So I feel like I deserve some credit for day 19. And then the other one, I think it was day 11. I was nowhere near figuring out, yeah, Plutonian pebbles. I don't think I would have figured this out. I had to look at somebody else's code to figure out that, like, do we have it here? Yeah, you have like multiple copies of 48. So after a lot of blink iterations, you end up with lots of duplicates on your list. Like lots of 48s, lots of 40s, lots of 20s, lots of 2s. And then the optimization is that you just count how many of each duplicate there is, and you have like a compact version of this list. That's just the count of each stone ID rather than a list of every stone, including a bunch of duplicates. Yeah, so day 11, I definitely needed help. Day 19, if I had to say I cheated or I didn't, I would say I did cheat for day 19. So take a star away from me there. I got part 1 by myself, but part 2 I had to look at somebody else's code. And then maybe there was a third one that I'm forgetting about. I know day 16 was hard, but I think I got it. Yeah, I think I did it off stream. I didn't even upload day 19 yet. I was so tired after yesterday. Okay, day 17. Day 17 was tricky. Because if I only did part 1 on stream, then that's some indication of difficulty. Oh, the int code? Oh yeah, I totally had to. I really cheated for 17. I didn't even understand the code that I looked at. I just sort of ported it line by line from Python into syntran. And at least there wasn't recursion, because sometimes I have difficulty coming up with an iterative version of a recursive algorithm. But for this one, I found somebody's Python code that was just iterating, and it called a function. And I can do functions, I just can't do recursive functions. So this one, I didn't even understand the code that I copied for part 2. I did try to brute force this, and then I actually did every single 32-bit number. And then my code crashed after it got to like 2 billion, because that's the max 32-bit number. It ran for 12 hours and then it crashed and I didn't have an answer. And that makes sense because the actual answer is like 20 quadrillion, 20 quintillion, something crazy, something astronomical. Okay, yeah, let's commit day 20 here and maybe find somebody to raid if anybody is streaming tonight. both parts today. It's nice to get one that's not incredibly difficult. I really needed a break after yesterday. Did that push? All right, that pushed. Let's find somebody to raid. What's J.W doing? I just raided Zorchenheimer like a week ago. Tetris in assembly. I think that's the same thing he was working on last time. J.W is coding in Swift. Musical instruments. Yeah, I don't think I'm going to find anybody else doing Advent of Code right now. So I'm going to give J.W a raid. These names case sensitive for raiding. Okay, it says the raid is created. Yep, that looks like the right profile picture. So apparently these are not case sensitive. That's good to know. All right, thanks everybody who tuned in. I really appreciate it, and I will catch you next time. Bye.
This is what I love about Xcode. Build failed, you can't see where. Here it is. Yeah, okay, so let's go through and just fix a bunch of these. So there was a way to select them all. I'm gonna go and do everyone. Oh, maybe not. Hang on. Select them all. No, I think it was build settings. Sorry, I'm wasting more time by trying to be clever here. That goes to 18.